Hello everyone, welcome back to my YouTube channel. So today we are going to solve day 14 problem of this month on LeetCode. Before starting, if you guys haven't subscribed my YouTube channel yet, then please go ahead and subscribe it. Now without any delay, let's get started with today's problem. Problem number 3454. Separate squares part 2. So yesterday we have solved part 1 of this problem, right? And today we are going to solve part 2, right? So this is part 1, problem number 3453, right? So in this problem, same problem statement is same, but only one difference is there, right? That is this line. So you are given a 2D integer array squares where squares of I, X, Y, L represents the coordinates of the bottom left point and the side length of a square parallel to the x-axis. We have to find the minimum y coordinate value of a horizontal line such that the total area covered by the squares above the line equals the total area covered by the squares below the line, and answers within this range, right, of the actual answer will be accepted. But here squares may overlap, same like part 1, but overlapping areas should be counted only once in this version. Okay, so let's see this example number 1, right? So these are two squares given to you, right? Square A, square B, right? So 0 0 is nothing but x and y coordinate, right? And these are the bottom left points, right? So here represents the coordinates of the bottom left point, right? So here for this particular example, so first 0 0, right? So 0 comma 0, and this one is length. Okay, so length and width, this is a square, right? So same length, same width. So area is nothing but length into width, that is nothing but 1, right? Same way here also area is going to be 1 into 1, 1 only, and here the starting point is this 2 comma 2, right? All right, this thing is clear, right? And we have to draw one line, right? Here y is equal to 1, so it can be any line, right? We can draw a line in between, like here, 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 anywhere, right? But since we need to return the minimum y coordinate value of a horizontal line such that the total area covered by the squares above the line equals the total area covered by the squares below the line, that's it, right? And these are the constants for this part 2. And see here in example number 2, so this time here 0 0 starting point, and here size is 2, so area is going to be 2 into 2 4, and here area is going to be 1, 1 into 1 is 1, total area is 5. But in this particular part 2, total area is going to be 4 because this is a duplicate region, we are not going to count this, right? Since the blue square overlaps with the red square, it will not be counted again. Thus the line y is equal to 1 splits the square into two equal parts, right? That's it. Okay, so this is a difference. If you see the part 1, right, let me show you the part 1. Okay, so this is part 1, right? So in part 1, if you see, same examples given, but only difference is overlapping area should be counted multiple times. And here if you see this example 2, so in this we are calculating this 1.16667 as the output, right? Because we are calculating both the areas, red area and blue areas, right? So red area overall is 4 and this blue area is 1, so overall is 4 plus 1 5, right? So when we are going to split when our y is on 1.16667, so we are going to get the red and blue area is 2.5 and above area is same 2.5, so add this y point, right? So this is a difference, but in part 2 we are not going to do the same thing. Okay, and as you see here, I have already written the code because code is going to be a little bit big, right? This is a hard level problem, right? So that's why I have written it so that we don't waste much time. Okay, but let me first explain what we need to do. Okay, here in this part 2 problem, right? Okay, so here let's say uh, this is your y-axis. Okay, and let's say this is your x-axis, right? Okay, and now let's say you have square boxes, right? This is one square box, right? This is one square box. Let's say this is one square box here. Let's say this is one more square box, right? And let's say there is one more square box here. Okay, so just treat these shapes as square box only. Okay, So what I want to tell you here, right? So see, for one particular square box, right? So in this square box, I need to calculate this complete area, but this is duplicate, right? This is duplicate. Here also, if you see, for this particular square, this is one duplicate and this is one duplicate here, right? For this square box, this is one duplicate. For this square box, this is one duplicate, right? So there are many overlapping areas, right? And it can be anywhere. It can be like here, or it can be until here, right? It can be anywhere, right? So we have to fix this issue, right? We have to fix this issue, right? So what I'm going to do here, we don't need to calculate the overlapping areas again and again, right? So what I'm going to do, I'm going to make this problem a little bit easy, simple. What I'm going to do, this is my y-axis, right? This is my y-axis and this is my x-axis. So in y-axis, I'm going to draw a few lines. Okay, so I'm going to draw one line here, because at this particular line, if you see, one square box is getting started. Again, I will draw one line here. Okay, again after that I will draw one line here. Okay, so when here this square box ends, right? So here I will draw one line, okay, like this. Same way, here I will draw one line, so like this. Okay, then here I will draw one line, right? So here, see, I am just splitting, right? I'm splitting the areas. Now I don't need to calculate, go over complete square box and then find the area and the overlapping areas. Now I just need to visit over these lines only, right? So in these lines, there is maybe square is getting started in the y plane, maybe square is getting ended in the y plane, right? So this is what I need to do here, right? So like this, right? So this is the first thing that I need to do. Now it is very easy, right? Now in this region I need to calculate the area, right? So let's suppose this is your prev y, and this is your cur. So in this area you are going to get what? You are going to get the width, right? Same way, when after this, let's say you move to this and this, right? This next time when this your curve moves up, right? So this is going to become your new curve value, and this is going to become your new pre value. Then in this case you already know the width, right? So width is very easy to find, right? Width is very easy to find, right? These are going to be different width. Now in this different width, right, we have to calculate the length, right? So right here, this is the length, okay, of one square box. Then after that we make a jump, right? Then in this also, if you see, we are starting from here, right? And this square box is ending here, but there is one more square box that is starting from here and that is ending here, right? Okay, right? So all these things, all these stuffs I need to take care. Okay, all these stuffs I need to take care, right? So definitely I need to check the different x points as well here. Okay, so let's say this is 0, this is 1, this is 2, okay, 3, let's say this here is 4, let's say it is 5, let's say something 6, okay, like this, right? And here maybe you can, for simplicity, you can say this is 0, 1, 2, 3, 4, 5, okay, something like this. Okay, but just treat them as square boxes, okay, right here, same length. Okay, so this is what I'm saying, right? So first thing that you need to do here, right? So first thing that you need to do here, you have to create the events, right? So in the events, right, so this is one square box, right? So from here it is starting, right? This is your x, this is your y, and this is your length, right? So if any square point is starting from here, so in y axis you have to take care of this, right? When it is ending, when it's starting. So whenever any square box starts, so during that time, just add type as +1. Okay, just type as +1. +1 means you are adding a square box, new square box. And when you add type equal to -1, that simply means that you are, that square box ends, right? So here, if you see this case, so y is 0, right? Starting from 0, right? and there is one event which is occurring here, and there is one event which is occurring here, right? Okay, so at y is equal to 0 we are adding, and at y is equal to 1 we are removing, right? Okay, so you can say -1, because in code I'm using -1. Here I'm just simplicity, I show you remove, right? And your x will be nothing but starting from this 0 up to this 1, right? So x is 0 in this. If you add this, right, this is nothing but the ending point, right? So starting is this now, so length is 1. So here is said, if this side you go to with the length 1, so you are going to reach here, so that is nothing but this x plus l, right? So here I'm writing just x, right? Here I'm writing x plus l. Okay, okay, right, clear? Same way here, at y is equal to 1 remove, and same x. Then here there is one event is going to occur, so I'm going to add a new square box, right? So this is the start of it. So add, type is add, y is 2, right? Add 2, this is happening, and x is from 2 to 3, right? 2 to 3, so 2, 2 plus 1 3, okay, x plus l, right? Same way at this one event is occurring, right? So remove event and this. Okay, so this part is clear. I hope that this part is clear what I'm doing here, right? Same way, let me show you for the example number 2. Here you see one event is going to occur here, one event is going to occur here, and one event is going to occur here. Okay, now see, in this case first you are adding, okay, 0, type add, and x 0 to 2, right? Next time I am not adding for this red color box, right? 0 and then add 2. I am instead of this I have written here for 1, right? So that simply means I am sorting the events, right, based on the y value. Sorted the events based on the y value, based on y value. So after that, this is the next event, right, at 1. So at 1 you see a new box is getting started, so add, and x is 1 to 2, right? Then at 2 you see first you have to remove this red color box, 0 to 2 you are removing it, right? Then this box also you need to remove, right, 1 to this. Okay, so this is the first thing that we have to do in our code, right? Okay, so for this one, this is the code, right? Let's say sweep event. Okay, so we are scanning based on the lines, right? Scanning based on the lines, right? So for any event I'm adding the y value, right? I'm adding the type +1 for add and -1 for remove, right? I'm creating a class, and I am passing x1 and x2. X1 is nothing but the starting point on the x-axis, and x2 is nothing but the starting point plus l, the width, right? So that is what I'm going to pass. So these are the class variables, right? And I'm just passing them in this constructor of this particular class that I've created, right? So basic thing I'm doing here, right? This is the first thing that we need to do, right? So here just see this highlighted part, okay? Don't see anything else in the code, otherwise you guys will get afraid. Okay, so don't see anything else as of now. I will make it very simple for you. Okay, and this is the main method that is given in our code, right? So in this main method I'm going to create one array list of the events, right? So all these events I will add them to one array list. Okay, so for all these squares that is given to me, I will iterate over these squares one by one. Just go over the highlighted part. Okay, then I will find out x, y, and l. Then in the events, first thing I have to add the starting of that square box, and I have to add the ending of the square box. For adding I am writing +1, and for removing I am writing -1, right? And starting is y, right, because only in the y axis we need to take care of this, right, as of now. And here y plus l is the ending, right? And here x and x plus l is the same, right? So this is what we are doing here, right? This is what we are doing here, right? Here, right? And x and x plus l we have to add, right, side by side, right? Clear this part here if you see in the debug statements, right? Okay, now also in the events side by side I will also add I will create one set, right? In set I will store the double type values, right? And here in this I will add all the points that I am seeing in the x plane, right? So x-axis, right? So I will add x and x plus l both here, right? So all this stuff I'm adding side by side in the x set, right? Okay, now after that, what I will do here, this is a set that I'm taking, right? And in the set now I have unique elements, right? Definitely I have unique elements. So let's suppose you have two boxes like this. One is from 1 to 2 and other is from 2 to 3, box A, box B, right? So both the points are ending at 1. Same, both the boxes, if you see, there's one common point. One is ending here and one is starting here, right? So we don't need to store the duplicates, so that is why I'm using set first. And here I will store all these points, right? What are the different points, right? Here 1.0, 2.0, 3.0. And definitely if I have different boxes, then here I have to store all the points, 2.0, 3.0, 4.0, right? But if I have two boxes, one is like this and one is like this, so can I store one here, then for this ending is 3, for this one starting is 2, 4. So can, for this box A, can I add 1 then 3, and for other box then I add 2 and 4? No, because I have to check in x axis also in one order, right? So I have to do the sorting on this as well. And definitely I don't need to store the duplicates also from here. This thing is clear, right? So that is why I'm creating one set, and in the set I'm adding, right, wherever anything happens on the x axis also I'm taking care of this, right? So now after this, I'm going to convert this set to a double array, right? So create one double array. So here, see, double array I'm creating right here, and this is a set I have. I'm going to stream over all the elements of this set, and I'm just going to map the elements, and then after that I will do the sorting on this, and I will just change it to array, right? So this is the concept of stream API, right? In the Java 8 plus we have this, right? So this is just a one line code to do this sorting and change to array, right? If you do if you want to do any other implementation here for the sorting, right, you can also do that, right? Instead of uh, just writing stream, you can maybe sort over go over all the elements and then uh, do the sorting and all that stuff, right? So whatever you want, you can do, try that. Okay, so this is one line solution for that. Okay, and then after that, what I will do here, I'm creating one hash map, right? And hash map name is in x index, right? And the keys is going to be of double type, and in the integer I will store the indexes. Why I'm doing that? Okay, so this is uh, the array, double array that I've created. So I will iterate over all the elements, right? And all these values, right, whatever I will get, I will store one index in front of that, right? Okay, so whatever different values that I will see here, right? So 1, 3, 2, 4. After that, after sorting, I will get 1, 2, 3, 4. So for all this I will just give one indexing. Why I'm doing that? Okay, so reason is, let's suppose this is your y-axis and this is your x-axis, and let's say you have one box here, and let's say you have one more box here. Okay, and now different events you already know, right? This is one event, this is going to be one event, right? This is going to be one event, then this is going to be one event, right? And let's say this is 0, this is 1, this is 2, this is 3, this is 4, this is 1, this is 2, this is 3, this is 4, right? Now here if you see, here if you see, this is very easy, right? The width calculation. So this is my cur, this is my priv, this is my cur. Next time this is my priv, this is cur. So this is going to be my width, then this is going to be my width. So width calculation is easy, right? But now the issue is how to calculate the length here, right? Overall length, because area is nothing but length into width. Width we know, length we need to calculate, right? And length may be like this here, or maybe some other box somewhere here, then this length also I need to calculate. So I need to take care of the this length, right? Okay, so how I'm going to do that then, right? So let's suppose you are here, so here to here you have to calculate the area, then here to here you have to calculate the area, then here to here you have to calculate the area, right? Okay, but if you see this, let's suppose your y is here at this particular position, right? So in this, so this these are different points that you need to take care, right? So there are different ranges, right? Here different ranges are here, right? So whenever you have to combine, right, the different areas, and you have ranges given to you, right, you have to iterate over the ranges, and then you have to calculate the answer. So in that case, segment tree should come in your mind first. Okay, segment tree, right? So segment tree itself is used for this range queries, okay, to get the evaluate the range queries. So segment tree is useful for that, right? So in segment tree, basically we play with the indices, right? We play with the indices. So here you have different coordinates, like let's suppose uh, 1 2 then 3 then 4, right? So you have to store all of this stuff in indexing, right, in these indexes, right? So this is why we have to use the segment tree. Okay, so now here events dot sort, this you already know, right? So I have explained that we need to sort the events based on the y, right? And then after that I have to create one segment tree, and in the segment tree I'm just going to pass this access, right? Okay, now once this is done, right, once this is done, then we have to calculate the total area. This segment tree, let's say this segment tree is going to help me in calculating the overall length, right? How it is going to do that? Let's discuss that. Okay, right. So in segment tree, right, we have a tree like structure, right? So let's suppose this is 1, then here we have, let's say, 2, then here we have this 3, right? So in segment tree, just keep one thing in mind: we always start with one index. Okay, we always start with 1, right? Root as 1. Okay, then why? Because if this is 1, right, if your parent is 1, then it's very easy to calculate the left child and right child. You have to just apply this formula, right? 2 into where your root is, right? And here 2 into where your root is plus 1. So here 2 into r is 1, right? So 2 into 1, so left child is 2, right? Right child is 2 into 1 plus 1, that is 3. So you are getting correct, right? Okay, same way here, if you, let's say, it has children like 4 and 5, it has children like 6 and 7, let's say. So now when, just see this part, okay, if this is your parent, then 2 into 2 is 4 for the left child, 2 into 2 4, 4 plus 1 is 5, that is for right child. So simple formula, right? Right. So it helps, right, in this. Okay, and here we have to calculate the total area first, right? Okay, so let's say I calculate the total areas, right? I calculate the total area of different square boxes I have, right? So let's say total area comes out to be x, or you can say uh, a. Okay, total area comes out to be a. Then my target area is going to be half of this, right? This is the target area. Target area is going to be half of this total areas, right? So now once I know the, let's say I calculate the, this is total area, right? I have to calculate, let's say I calculate the total area, right? Okay, then after that target is going to be total area divided by 2, right? Okay, now after that what I need to do, let's see. This is your y-axis and this is your x-axis, right? So here again I will create few boxes, right? So let's say this is one box, this is second box, right? And then let's say this is third box, right? And you can take few more boxes if you want. You can take, let's say, this as one more box. Okay, yeah. So now again the events, you already know that one event is going to occur here, 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 right? One event is going to occur here, right? One event is going to occur here, one event is going to occur here, right? One event is going to occur here, right? And you know that we are iterating like this, like this, like this, like this, right? So y is already sorted, right? Okay, and two y's can also be same, right? This part you already know, right? Y, two y's can be same here. See, two y's are same here, right? So in this case you will not get any area, right? Because events I already sorted, right? If you see here, one event is here and one event is here, right? Okay, if your y is here, previous and current both, right? So both the events are occurring at same place, because here one square box is ending and one square box is getting started here, right? Okay, but let's discuss this first, right? Okay, so now what we need to do here, so you get the total area, right? So I'm explaining what we need to do when you are near your target area. Okay, so let's see this part. Okay, so total area, let's say total area, a target is your a by 2, right? And let's say until here you get some area a1, and a1 is less than your target area that you need. So if this is the case, we are happy to proceed now. Until here result is not possible because my a1 is less than target, so definitely I will move my y up. Okay, my y is going to move up. Okay, my y is going to move up, right? Okay, now let's say when my y is going to move up, right? So when my y is going to move up, so this is my curve y and this is my prev y here, this part, right? I see that in a1, which was less than target previously when I was here, right? When I was here, so in a1, if I add the new this is, let's say, one slab. Okay, if I add the new slab area, then the output is coming out to be greater than the target, right? So here if you see, in the area so far I'm always adding the slab area, but in case when I plan to add the slab area, if it comes out to be greater than equal to target, if it comes out to be greater than equal to target, right? If it is not greater than equal to target, then definitely I will add this slab area freely. But if it is, if right now by adding this slab area, if it comes out to be greater than equal to target, then I have to think about the minimum y that I should return. Okay, right? So let's say this is your y1 and let's say this is your y2. So until y1 answer is possible, when until y1, let's say a1 is the total area, answer is possible. But when you add y2 also, until y2 there is one slab, that is nothing but a y2 minus y1, this slab you have added, right? This is from 0 to y1, let's say, and this is y2 minus y1. So okay, this slab you added. Okay, then your area comes out to be greater than equal to target. So definitely I will not add completely this slab, so I have to choose the minimum y value here, right? Minimum value of h that I need to raise above, right? Definitely the length is going to remain same, right? Length is going to remain same. Now it depends on me whether I want to take this complete y2 until here, or maybe I will stop my y2 here only, right? Because length is going to remain same, right? Until here no answer possible, but here until here I need to find one h value, right? Which I should add so that I get the half area, right? So what I need to do here, right, if this is the case, then what I need to do, so what is my target area that I need, right, minus from this target area that I need, right? From this I will subtract the area that I already have calculated so far, area so far, right? So I will get the remaining area that is the requirement for me. Okay, remaining area is the requirement for me, right? Now from I need this remaining area, but my height should be minimized, right? This should be minimized, right? Okay, now area is nothing but length into width, right? Length into width, right? You can write w, right? And length is constant, length will remain constant, right? So height, right, that is width, right? So width you can say is area divided by l, right? So if in this remaining area I will divide the length, okay, I will divide the length, right? In this remaining area, if I divide the length, okay, let's read it length as of now. Okay, length. So I will get the height. I will get the height or width, height. So until y, until this, okay. So what I get now? So until here result was not possible, right? Until y1, right? So in this, instead of adding a complete new slab height, I will just simply add the new height, right? So until here, instead of directly jumping to this position, I will add this. So this is going to be my output, right? So this is the logic that I'm planning to use here, right? I hope that this part is clear, right? So here I will go one more time. Okay, just go over the highlighted portion, right? So let's say you get this one total area and you divide total area by 2, so you get the target. Okay, now this is done. Now after that, you are iterating over all the events one by one, right? You are iterating over all the events one by one, right? And you will get slabs one by one, right? So if with the addition of this slab area we don't reach the target, so just happily add this complete to the area so far. But if in case when your area so far and you do the addition with slab area, if it becomes greater than equal to target, then find the remaining, and the remaining divided by length, you get the height, and I just add it in the previous y, so you will get the output, your final output, right? So this is actually what we are returning in the end, okay, in our code, right? This part, right? So I hope that this is clear, right? What we are doing here, right? Okay, now let's discuss this a little bit more, right? So here, let's get starting from here itself. So this thing is clear, right? Here this clear sorting segment tree we have created, right? And total area you are taking 0 initially, right? Just go over the code, and the previous y initially. So first event, right? First event at 0 position we have the y value, right? So first event dot get 0. So first events dot get 0 means the first event, right? We have already sorted the events. So from the very first event, get the y value. So this is going to be your prev y for very first case. Okay. Then you are iterating over the events one by one. Again, your curve y is going to remain same as of prev y, right? Here again we are iterating over the events and curve y is equal to e dot y. Now total area is equal to total area, which is 0, and here st dot length plus into curve y minus pre y. So this is going to become 0 as of now, and total area is going to become 0, right? Right. And then you are going to get the L and R value. Okay. But what is this st dot length 1? Why I'm writing this 1, right? So because in your segment tree you are always starting from 1, right? So in 1, definitely this is parent, so definitely I will store the result. Okay, so let's draw the diagram and let's explain it. Okay, so let's say this is your, again I'm drawing same thing. Okay, x-axis, y-axis, there is one box. Let's say there is one box. 1 second, let me place it here. Okay, let me place one box here, and let's place one more box here, right? So in this case, this is one event, this is one event, right? This is one event, this is one event, right? And this is 0 1 2 3, 1 2 3. Okay, first you need to get the events, right? So here again events are like this. So from 0, right, one event is getting started, right? And this is add, right, plus 1, and 0 to 2 you have, right? Same way. Then after that 0, again this particular event, right? This event is ending at 2, right? And here minus 1, 0 comma 2. Same way this is starting at 1, right? And here addition of this plus 1, and here 1 comma 3, right? And it is ending at 3, and here minus 1, and here again 1 comma 3, right? So these are the different events you have created, right? Okay, This thing is clear. First part is done, right? Okay. Now after that, once this is done, so now here different x also you have to add. So you have different x like 0 2 1 3. So you have 0 1 2 3. Okay, all this stuff you have, right? All this stuff you have, right? Okay, now this part is done, right? This part is also done. Now after that, total area you need to calculate, and previous you are going to take 0 initially, right? So different events like this now. So so what are different events you have, right? So these are different events, right? Event 1, let's say, event 2, event 3, event 4. Okay, all these events are occurring, right? Okay, so now here what you are doing after that? So events, and here you did the sorting. Okay, all these steps are done, right? Then total area is 0 initially. Y is equal to events dot get 0 first event, right? So first event dot get 0 first event dot y. So this is y, right? So you are going to get y equal to 0. This is nothing but type. This is nothing but x1. This is x2, right? Let's do the dry run. Okay, right? So this is done here, and then after that you are iterating over the events. So cur is equal to e dot y. So prev is also equal to 0, and cur is equal to 0. So both is going to make this total area 0 as of now. And L is equal to x index dot get e dot x1. Okay, L and R you are passing. L is for this particular event, L is passing as 0, and R is you are passing as 2, right? I'm clear, right? This part. So e dot x1 and e dot x2. Okay, then you are calling this st dot update. Okay, so here you are calling st dot update, and now in this, see carefully what we are doing. Okay, this is important. So I am always starting from 1, right? I am always starting from 1. This part clear? I am always starting from 1 here, right? So here I am passing 1, then I am going to write 0. Okay, and then here what is the length of this length is 4, right? So this is nothing but x s dot length minus 1. 4 minus 1, that is nothing but I will add 3 here. Okay, simplicity, I will add 3. Okay, and so 0 to 3 you have, right? So these are different points, right? So this is 0 index, 1 index, 2 index, 3 index. Okay, all this stuff you have, right? And then after that, here you are passing L and R. So L and R is 0 and 2, and then after that you are passing E dot type. So E dot type event type is +1 here. Okay, so this is what you are passing here, st dot update, and this part. Now let's understand this part, how you are going to solve it. Okay, if you solve this, definitely this problem will be very easy, right? Because we have to do the same thing for this, same thing for this, same thing for this, right? So now I'm going to iterate over this code, st dot update, right? Okay, so again I make a jump to this part. Okay, this segment tree. So segment tree for the union length on x-axis. So segment tree we are using for the calculation of the union length on the x-axis, right? So in segment tree, what I am passing? I am passing n, right? The length or a length, the xs, the array, right? For the x-axis, whatever the different values, and I'm going to pass the cover and the length. So length is going to calculate the total length, and cover is going to calculate the that particular interval, right? It is covered by how many different square boxes or nodes, right? I am saying nodes because I'm build draw the tree diagram now for this one. Okay, now here update, right? So in update, it is saying that when your ql is greater than equal to r, right? So here idx lr. So in update method, right? So we have idx, we are passing this as l, we are passing this as r, right? So this is the overall range. This is what I need to search, ql, qr, and this is a type. Okay, so this thing is clear, idx lr ql qr and type. Okay, so now I am saying that here your L is here, R is here, right? And your QL is here, and QR is here. Right? That right this part. Okay. So now here tell me, QL is greater than equal to R. Tell me, QL is greater than equal to R? No, right? Or your QR is less than equal to L. QR is less than equal to L. No, right? So this is not the case. We are not returning. But if your QL is less than equal to L, right? QL is less than equal to L, and your R is less than equal to QR. R is less than equal to QR, right? So this is also not the case, right? Right? So in that case, we are calculating the mid, right? We are calculating the mid. Okay. So now there is going to be twist here. Okay. So 0 to 3 is the overall that you need to find, 0 to 3. And remember, in segment 3, this is inclusive and this is exclusive. Okay. Right. So 0 to 3 I need to find, but right now 0 to 3 is the overall, but I am searching for this one, 0 to 2, right? So I don't have any answer yet. I don't have any answer yet. So what I'm going to do, this is one node, this is node 1, let's say. I'm going to create the child of this, right? So how we calculate the child? That is very simple. So this L is equal to 0, R is equal to 3. I'm going to calculate mid. Mid is nothing but 0 plus 3 divided by 2, that is 1, right? So mid I'm going to calculate. Okay. And mid I'm going to calculate. So here I will write 0 and 1, mid until 1. Here I will write 1 starting from 1 inclusive and until 3. Okay, like this. Like this. So now in these two nodes I have to search. Okay, in these two nodes I have to search, right? This part is clear. Update. And here index you already know, right? So left child is nothing but, I told you, root, wherever root is multiplied by 2, and wherever root is multiplied by 2 plus 1 is the right child. Okay. And then after that, see, L and mid I'm passing this q1 and qr. This is same again, q1 and qr, because I'm searching for 0 2, right? This is same, right? This is what I'm doing here, right? Okay. and and after that this cover of index value, right? Cover of index. So all these values as of now they are 0, right? Cover of index value that I have created. Okay, one more thing, why I'm taking the size 4n, 4 into n. So these things also I have explained actually here in this part, in this particular problem. Okay. This fruits into basket 33479 problem, right? So in this I have attached the definitions of segment tree. So maybe you need to batch from 6 minutes to maybe around 30 minutes. It's, I just talk about the segment tree, like when we need to use that and why length is 4 into n, right? So if you want to see in detailed information, you can check this particular video. But in this problem also, let me show you why I'm writing 4 into n, right? 4 into n array that I'm creating for the cover and the length, that is just for a safety purpose. Okay, just for one safety purpose, right? So left child, you will get the output of the value from the left child from 10, and from the right child at 11, right? If your n is equal to 5, right? Let's say, right? Okay. So now for the same purpose, even with 3 into n your problem may work, right? For, but for safe side, okay, so that we don't get any out of bound type error, right? So what we do, we simply take 4 into n as the array size for the same purpose, so that we don't get the outbound array, right? Outbound index type error in the array, right? So that's the purpose of this. Okay. So that's why I'm taking it 4 into n, right? This cover and length, right? So here ql and qr remain same, right? And now cover index is, if it is greater than 0, right now it is not, right? And here if you see l plus 1 equal to r, right? L plus 1 equal to r. So in that case, right? So here this is 0 1 and this is 1 comma 3. This two part I need to solve, right? So let's see this part first. 1 comma 3. Okay, 1 comma 3, right? So 1 comma 3, right? 1 comma 3, right? So 1 comma 3 is nothing but here again pass 1 comma 3. Okay, so you have to pass like this, right? So this is the overall, right? 0 3 you have, and now you are passing 1 3, 1 and 3. Let's say this is your L and this is your R. Then QL and QR is again same, that is 0 comma 2. So 0 0 comma 2. Now it is like this, QL and QR. Okay, now in this case QL is greater than equal to R, QL is greater than equal to R, no. QR is less than equal to L, QR is less than equal to L, no, right? So we are not returning simply. Now see this case, QL is less than equal to L, QL is less than equal to L. Yes, it is true, right? And here it is saying R and operation, right? And R is less than equal to QR. R is no, right? So it's not completely covered yet, right? So this I haven't implemented yet, right? Now again we have to do the same calculation, okay, for this part, right? So again here let me just erase this part. Okay, let me just erase this. So again for this one you are going to calculate the mid, right? So left is 1, R is 3, so mid is going to be 2, right? So you are going to get 1 comma 2 here, and here you are going to get 2 comma 2 comma 3 here, 2 comma 3 here, right? Now see, this is done, this is done, right? Now after that what you need to do, after that let's say you try to solve this. Okay, 1 comma 2, right? 1 comma 2. So 1 and 2 is the L and R. Okay, and QL is again, QL is again 0 comma 0 comma R. Okay, this. So now here QL is this, right? So QL and QR you are going to pass the same thing here, right? And LR is 1 comma 2, right? Now here in this case if you see QL is less than equal to L, right? True. And then R is less than equal to QR, so this both are true, right? Both are true. So L and R is this, right? And your QL and QR is this. This is what you are searching, right? So now what you need to do here, from this side you are going to return the length 1, you are going to return the length 1. Okay, so cover, you are going to update the cover value. Okay, cover index. Okay, cover index. So this idx value, what is this idx value that we are going to get? So idx is nothing but this idx into 2 plus 1, right? So initially this index is 1, right? This index is 1, so definitely this is going to be 2 and this is going to be 3. Same way for this 3, this is going to be 6 and this is going to be 7, right? So from this 6 actually you are going to return what, 1 here. Okay, now same way here, this is clear, right? QL is less than equal to L, then cover index I'm updating. Okay, not returning yet, I'm just updating cover index. Okay, cover of 6 I am passing it 1. Okay, now here right, after that what I need to do after that? Okay, so this value, right? So in this value if you see, you pass this R. Okay, Q1 QL and QR same, and mid and R. Okay, mid and R. So mid and R you need to pass. Okay, so in this case when you pass this, so what you are going to get? So again let's write this now. Your L, let's say 2 and R is 3, right? And same way if your QL is fixed, right, 0, and R QR you have to find until 2, right? This is what we are doing, QR is until 2, right? So now if you see this case 0 2, right, this is fixed. So now if you see your code here, so QL is less than equal to L, right? And QR is also less than equal to R, is also less than equal to QR. This is valid or not? No. But if you see above case, QR is less than equal to L, so QR is less than equal to L. Yeah, it is true here, right? So from here we are simply returning nothing, right? So overall at 1 3 we have just 1. Now 1 and 3, so from here 1 and 3 you are simply going to return above what, you are going to do the backtracking here, right? Overall, so in this, in the else part, right, overall for this one, length is going to be the value that you are going to get at this index into two, the left and right child. Okay, you are just going to do the addition of this, and that's what you are going to update here. Okay, length of index. So this is what you are going to return 1 here, right? So overall 0 to 3, if you see 0 to 3, right? So here 0 to 3, right? So this 1 you are returning here, right? And 0 to 1, let's see 0 to 1, what is the output? Okay, we didn't see yet for this 0 1, right? Let's see. So L is 0 and 1 R. Okay, and your QL is 0 0 to 2, right? 0 to 2, right? Like this QR, let's say 2, and QL, I think it's starting from 0, right? Here okay, so now in this case, see what is going to happen. So QL is greater than equal to R. QL is greater than equal to R, no. QR is less than equal to L. QR is less than equal to L, no. This case doesn't exist, right? Now QL is less than equal to L. Yes, it is true, right? And tell me, R is less than equal to QR. Yes, it is also true, right? So in this case, cover index I am incrementing, right? And if cover index I am incrementing, so length is going to be updated at this particular index. So at this particular index, length is going to be updated, right? Okay, and here also length is 1. So this length is dependent on this one and this one. So overall sum is 2, right? We are not returning actually. If you see, we are just updating the length every time, and we know that parent length is dependent on the left child and right child, right? So this is how we are just going to update the cover and length array, right? So that is right, because from 0 to 3, the overall length you have seen is 2 as of now, right? This is what you have to return. Okay, so overall length you have seen as 2, okay, as of now. Then after that, once you get the total length here 2, okay, right, then this your current curve y is going to become the priv y, right, and then here next time you are iterating for the very next event. So in that, again you are taking a new curve y, and then you are going to calculate the total length. So this is nothing but the previous that you have calculated as of now, sd dot length 1, right? So that's what, okay, so that length you have calculated as of now, right? So that is nothing but 2, and then curve y minus pvy, what is the difference between them? Okay, so next time you are making the jump to here, okay, here, right? Initially you are here, so now you will get to the area, right? 0 to 1, this 2 into 1 2 area, okay, you get the area. Okay, then after that, L and R again for the next iteration, right? Again L and R. So L is starting from here, right? And for the next event, right? So which is this plus 1, okay, 1 2 3, this is what you have to pass, right? And again for this you have to call this st dot update, right? So st dot update, again you go here, right? Again you go here, update, right? In this update method, just again check this. Maybe you can try copy, pick copy pen pencil, right, and try this. Okay, and again just check this. So here you are just updating the cover value. So cover value, right, if any square box, let's suppose one square box here, one square box here, so if it is already, this square box is already covered by this, na, and then this is also covering this, then in that case we don't need to calculate it more, like, then in that case we don't need to calculate the length, right? So that is the purpose that here if you see I'm writing it like this: if cover index is greater than 0, right, then simply calculate this, right? And this is for very leaf node, right? If cover index is 0, right, if it is not greater than 0, and if you see this case L plus 1 is equal to R, simply update the length of index as 0, right? Okay, for that particular point, right? And otherwise you have to take if cover index is 0, and then in that case, if it is not greater than 0, right, if it is 0 and this is not the case, right, L plus 1 equal to R, that's it's not leaf, then in that case definitely for that particular parent we have some children, and from there, from those children we will get some value. So that is what we are doing here, right? So I hope that you guys little bit clear, right, what I'm doing here, right, in this segment tree, right? So this is segment tree, and this thing you already know, right? Now what we are doing, right? So we have moved over all the code, right? I think as of now this is what I have covered. So here this is what you need to do, right? I hope that you guys are clear, right? So in the end you will get some total area here, right? Once you get the total area, you have to divide it with 2, you will get the target. And then this is the second sweep, right? So I told you once we calculate total area, then we need to calculate the half, right? So again, for that purpose, I'm going to fill this cover and length, right? So cover and length that we have calculated for the overall, right? So cover and length we have calculated for overall, right? In one go, we are not updating it again and again, right? We are not updating it again and again, right? Right? Okay. So this cover and this length, they are defined in the class level itself, right? So whatever the value we know, we are just updating them again and again, right? But here we need to reset it for the second sweep, right? And then again take one pre by this thing is same, right? Slab area you need to calculate, and this part I already explained, this part. Okay. And this part again, L and R you have to get, call this method pre by you have to call. We are never going to reach here, okay, this and pre by, right? This is just, we are always going to return from here, I think. Okay. So this is what you need to do. I hope that you guys are a little bit confident on this problem now, right? We iterate over all the lines of this code, right? And if you guys still have any questions, then please feel free to ask in me in comment section. And please watch this, okay, this particular one, right, for the segment definitions and all, right? Very important. Okay. I will try to make one separate video of this maybe on segment 3, because this concept, right, it needs a separate video, right? So let's submit this solution and let's see. So see, our solution is accepted, right? So this is the complete solution, right? So I hope that you guys are able to understand today's problem, and if you guys still have any doubts, then please feel free to ask in comment section. Till then, keep coding and keep practicing. Meet you in the next video. Thank you. Bye bye.